Hello students, welcome to the platform of Infinity Vision. Today I am here to discuss with you a detailed solution of physics paper of JEE Mains January shift that was conducted by NTA on 27th of January 2024. So this paper is of morning shift that the exam was conducted from 9 AM to 12 PM. So in this video we will be going through the detailed solution of each and every questions so that you can have a check on your performance on the day of exam and can match what kind of score you will be scoring. So let's start. So as you all know that the complete paper is divided into two sections, section A and section B. Section A will be objective type questions, MCQ questions consisting of total 20 number of questions, and section B will be numerical answer type in which there will be 10 questions and only 5 has to be attempted. Okay, so we are starting from section A. So the first question of section A is basically a pure kinematic question, a very simple question of kinematics. The question says that position of an ant S in meter moving in YZ plane is given by S equal to 2t square plus 5k cap. So this is the position vector or of a particle where t is in time in seconds. The magnitude and direction of velocity of ant at t equal to 1 second will be. So the position vector of particle is given. Position vector of particle is given. This is equal to S vector equal to 2t square j cap plus 5k cap. This is the position vector. And what is being required? The velocity of the ant is required. So it's simple. The velocity vector we all already know that it is the differentiation of position vector ds vector upon dt. So if we differentiate this, we will be getting 4t j cap. And since the z component is constant, so it will be 0. So the differentiation will be v vector equal to 4t j cap. Now the time is 1 second. Simply we have to substitute t equal to 1 second over here. So the required velocity that we will be getting at t equal to 1 second will be 4 into 1 j cap, and it will be 4 j cap meter per second. So this is the vector form. The magnitude of the velocity is 4. That is, speed is 4, and it is in positive y direction because the j cap is coming over here. So the correct option is 4 meter per second in y direction. So option 4 is the correct option for this particular question. As you can see, it's a very simple question on kinematic parameters. This is a very basic differentiation that they have asked. Now next, moving to the next question. Question number 2. This is an assertion reason type of question, statement type question, purely theoretical. So what the statement is saying, viscosity of gas is greater than that of liquid. The question is, the first statement is viscosity of gas is greater than liquid. It is absolutely wrong. It's absolutely wrong. Viscosity of gas is lower than liquid. Liquids are more thicker, they are more viscous. Okay, this is false. This statement is false. And reading this statement 2, surface tension of liquid decreases due to the presence of insoluble impurities. Yeah, this is very basic information. As we all know that detergent powders that we add in water, which we call as surfactants, So the purpose of surfactants is to lower the surface tension of the water. So that the water has less affinity with its own molecule and has more affinity with the dirt molecule. So adding impurities decreases the surface tension. So this is true. So statement 1 is incorrect, but statement 2 is correct. So statement 1 is incorrect and statement 2 is correct. So the correct option is option number 2. It's a very simple question of surface tension. Correct option is 2. Now next, moving on to third question. Third question is, if the refractive index of a material of a prism is cot A by 2, this is the refractive index of the material of the prism, okay, where A is the angle of prism, then the angle of minimum deviation will be. Minimum deviation के बारे में पूछा गया है, refractive index ये दिया हुआ है. तो बहुत ही simple relation हम लोग जानते हैं optics में, geometrical optics में, refractive index of prism NP, it is given by sine of angle A plus delta minimum by 2 whole divided by sine of angle A by 2. This is the relation that we already know for a refractive index of a prism material. ये कहाँ से आया है? बहुत सिंपल है. अगर कोई प्रिज्म है और कोई लाइट रे उस पर इंसिडेंट हो रही है और ये रिफ्रैक्शन के बाद इस तरह से चली जाती है. Now this is the incident ray and this is the emergent ray. So if we produce incident ray and emergent ray, so this is the deviation. Now for deviation to be minimum, we already know that if this is a normal, then angle I should be equal to angle E, and here what is R1 and R2 that we are getting? this R1 and this R2. So R1 must be equal to R2 and I must be equal to E. This is the condition for minimum deviation. So using these two conditions, we arrive at this particular formula. Now, using this relation, we can simply calculate. It's just a pure calculation based. Now, prism का refractive index cot A by 2 दिया हुआ है. So cot A by 2 is equal to sin A plus delta minimum by 2 upon sin A by 2. Now we can write cot A by 2 as cos A by 2 and sin A by 2. So sin A by 2, sin A by 2 will be cancelled out, and we will be left with cos of A by 2 is equal to sin of A plus delta minimum by 2. It's a very simple relation. Now we can use the two trigonometric ratio. On the left hand side we have cosine ratio, on the right side we have sine ratio. So we will convert into single ratio. So we can write sine of pi by 2 minus A by 2, and that will be equal to sine of A plus delta minimum by 2. Now since the trigonometric ratios are same, so the corresponding argument will also be same, the angle will also be same. So the equating here the angle, we will be getting pi minus A by 2. This will be equal to A plus delta minimum by 2. ठीक है ना? So cancelling both side 2, what we will get? Delta minimum equal to that we will get here. Delta minimum is equal to pi minus 2a. So this is the required answer. Delta minimum equal to pi minus 2a. So the correct option is option number 1 itself. So this is the correct option, option number 1 itself, pi minus 2a. It's a simple question of geometrical optics that is based on a very popular formula of refractive index of glass prism. Now let's move on to next question. Moving on to next question, we can have the next question is: a proton moving with a constant velocity passes through a region of space without any change in its velocity. Just look into the question that they have used the term velocity. Now velocity is a vector quantity, as we all know that, and change in velocity will be affected either the magnitude changes or the direction changes, or both magnitude and direction changes. Then velocity will change. So we will have to take into consideration all these possibilities. Now, the velocity is, if speed use karta, if they would have used the word speed, then we will be focusing only on magnitude. Since velocity word has been used, so magnitude and direction both has to be taken into consideration. If E vector and B vector represents the electric and magnetic field respectively, then the region of space may have. So these four options are given, and we have to check what kind of possibilities can be. The velocity of proton has to remain constant. So if the force, if we try to write the equation for the force, so the force on a charged particle in combined electric and magnetic field is given by QE vector plus Q into V cross B. QE vector equal to Q into V cross B. Now Q into V cross B, this is the Lorentz component for the magnetic force that will act on the charged particle, and the first one is the electrostatic force. Now, for velocity does not to change, it means the particle will have no acceleration. The acceleration of the particle is 0. Acceleration of the particle of the proton has to be 0. It means only then the velocity can remain constant both in magnitude and direction. Now, from Newton's second law, if acceleration has to be constant, then the total force acting on the proton must be constant. Now, in combined electric and magnetic field, there are two types of forces. As we can see here, this is the electrostatic component and this is the magnetic component, Lorentz force. Now, how can the net force be 0? The first possibility is that both electric field and magnetic field are individually 0. Means the proton is moving in a space, in a region where there is neither electric field nor there is magnetic field. In that case, the net force will be 0 because E is 0 and B 0, then the total F will be 0. So the first possibility is that E is equal to 0 and B is equal to 0. First possibility is that E is equal to 0, B is equal to 0. What can be the next possibility? The next possibility can be E is 0. Second possibility, E is 0. There is no electric field in that space. There is magnetic field, but magnetic field is parallel to velocity vector, V cross B. What is V cross B? Cross product of any two vector is given by AB sine theta. We already know that. So if theta is equal to 0 degree, then cross product will come out to be 0. So if magnetic field and velocity vector both are parallel, then being non-zero, the net force will be 0 because V cross B will be 0. So what can happen? B is not equal to 0. It means B is parallel to V. B is parallel to V. Magnetic field is existing, but it is existing parallel to the velocity vector. So even that, the Lorentz force will be 0. So second possibility is that what can be the third possibility? The third possibility is that neither E vector is 0, nor this part is 0, nor B part is 0. Both are existing. Electric field is also existing in the region. Magnetic field is also existing in the region. But they are existing such that this component, the electrostatic component, is exactly equal and opposite to the magnetic component. Means F electric vector is equal to minus of F magnetic vector. This is the concept. If two forces are equal and opposite, then ultimately they will cancel out to be 0. So if electrostatic force and magnetic force both are existing, but they are existing in equally opposite direction, then also the net force on the proton will be 0. And hence we can say that the net force on the proton will be 0, so its velocity vector won't change. So the third possibility is that E vector is not equal to 0 and B vector is also not equal to 0. ठीक है ना? और ये दोनों नॉन जीरो इस कंडीशन में है कि दोनों एक दूसरे को कैंसिल आउट कर जा रहे हैं. So the correct option that we can see from here is E vector and B vector is 0. Option A is correct. Very good. E vector equal to 0 and B not equal to 0. This is also matching with our analysis. And the last option is neither E is 0 nor B is 0. If we look into this, in which they are saying that B is 0 but E is not 0. If we put B equal to 0 here, then obviously magnetic force nullifies. There is no magnetic force on the proton. But if this force, if electrical component is not 0, if electric field is not 0, then naturally there is a force. There is a force. And whenever there is a force, there will be acceleration. So undoubtedly, the velocity of proton will definitely change. So we cannot take this. This is the wrong option that they have provided. This is the wrong concept over here. So the correct concept, the correct options will be A, B and D. So the correct option is A, B and D, and the third option is correct for this particular question. This was a very basic question based on particular conceptual question from moving charges and magnetism chapter of electrodynamics part. Now moving on to the next question, question number 5. The acceleration due to gravity on the surface of Earth is G. If the diameter of Earth reduces to half of its original value and mass remains constant, then the acceleration due to gravity on the surface of Earth will be. This question is very, very basic question asked on the concept of acceleration due to gravity. What we know that acceleration due to gravity G is given by GME by RE square. ठीक है ना? Where RE is the radius of Earth, ME is the mass of Earth. Whichever planet we are considering, that planet mass and radius has to be substituted over here. And G is the universal gravitational constant. Since they are asking about Earth, so we will be using subscript E. Now, converting in the form of diameter, we can write 4G ME by DE square, where DE is the diameter. We know that radius is equals to half of diameter, so the 2 will go upside in the numerator part and it will become 4. So this is the acceleration due to gravity. Now what the condition they have imposed is that the diameter reduces to half. Very good. But the mass remains constant. There is no change in the mass of Earth. Okay. So the new acceleration due to gravity will be GME by now the 4. Now the new diameter is DE by 2, half of the original. So this 4 will again go up in the numerator, and this will be 4G ME by DE square. And this is what? This is itself G. So G dash equal to 4 times G. This is very simple question. 9th class question, I can say that. So the correct option is 4 times G. The acceleration due to gravity will become 4 times if the diameter of the Earth reduces to half of its original value and mass remains same. So the correct option is option number 4. Now moving on to question number 6. The question number 6 is, a train is moving with a speed of 12 meters per second on rails which are 15 meters apart. To negotiate a curve radius 400 meters, the height by which the outer rail should be raised with respect to the inner rail is. This is a question of circular turn without friction that we know when we study banking of roads, and there is a condition that we usually calculate, and the condition is tan theta is equal to V square upon RG. This is a very important condition in which the proper angle with which the outer side part of the road has to be tilted or banged, so that only normal force is capable of providing that necessary centripetal force, and the friction force is 0. The friction has nothing to do in this particular case. So if we use this concept, just we'll draw a basic schematic diagram. What they are basically saying that this is the situation that they have imposed. This is angle theta. Okay, this is the axle of the rail, and this is the inner track, and this is the outer track, and it is negotiating a turn. It is negotiating a turn whose radius is, let's suppose given r equal to 400 meter. This is the radius of the turn, and the entire rail is going in this direction. ठीक है ना? So the gap between the rail is 15 meter as far as the data of question is given. This is 15 meter apart, and they have asked what height with which the outer rail should be raised. This is the outer wheel, this is the outer wheel, and this is the inner wheel. This is the inner wheel, and this green rod, this is the axle of the rail. So this is a very simple question of banking of roads without any friction. So here if we can see that if we impose the condition tan theta equal to v square upon rg, so tan theta can be written as h by 15 from this particular right angle triangle, h by 15. The speed of the train is given as 12 square, means 12 into 12 upon radius is 400 into 10. G, the value of G has to be taken is 10 meter per second square. So here h comes out to be 12 into 12 by 4000 into 15. So the options are given in centimeter. So if we convert it in multiplied by 100, so 100 10 times it is 4 3s are 12, 5 2 5 3 2 6 are 12. So answer is 5.4 centimeter. So the correct option is 5.4 centimeter. So it's a very simple question. Okay, na? We can if you try to make the free body diagram, then this is the normal force, and this is the mg force. This is angle of banking. So this angle will be theta. So if we write the equation, then the first equation will be n cos theta equal to mg, and this is the second equation. Here will be n sin theta equal to mv square by r, because the necessary centripetal force will be provided by the normal component itself. So if we divide these two equations, we can arrive at this particular formula. So the correct option is 5.4 centimeter. The outer rail has to be raised by 5.4 centimeter so that the particular rail or train can negotiate a curve of radius 400 meter, what is being given in the question. So next, coming to question number 7. This question is based on simple PN junction diode. We have to check which diode is reverse bias and which diode is forward bias. It's a very basic question that we used to practice while studying PN junction diodes. Now the first figure, if we can say that we already know that in a diode circuit, this is the circuit symbol of a diode. This particular end is the P type and this is the N type. This is the P type part, and that is the N type part. So reverse bias they have asked. So in case of reverse bias, the reverse bias condition, the P type of the PN junction diode has to be at lower potential in comparison to the N type. If the P type is at higher potential, if potential of P type is greater than potential of N type, then it is the condition of forward biased. And if P is less than Vn, then it is the condition of reverse bias. So we have to check this particular condition, that in which case the potential of P type is less than the potential of N type. So here, the P type is potential is Vp is equals to 2 volt, and since it is being earthed, so Vn equal to 0. Here P type is greater than N type, so this is the case of forward bias. This is the case of forward bias. Okay. Coming to option number 2. Here P type potential is 0 because it is earth, and here V type potential is minus 5 volt. Again, the potential of P type is greater in comparison to N type, so this is also a case of forward biased. Coming to option number 3, here we can see that the potential of P type is 2 volt and potential of N type is minus 10 volt. So this is again a case of forward bias because the potential of P type is greater than that of N type. In the last option, as we can clearly see that Vp is 2 volt and Vn is 4 volt. So here Vn, the n-type potential is greater than the p-type by 2 volt, excess is by 2 volt. So this is the case of reverse bias condition. This is the case of reverse bias condition. So the correct option is option number 4. Very simple question on PN junction diode, in which we have to check the polarity of the p-type and n-type, and we have to come to the conclusion that whether the diode is in forward bias condition or in a reverse bias condition. Now coming to question number 8, identify the physical quantity that cannot, these are the mistakes that the student usually do in the exam. Cannot is given, that's a negative statement, cannot be measured using a spherometer. A spherometer is basically a device which is used to measure the radius of curvature of any curved surface. If you go into a basic construction of the spherometer, then it will look like this type. It will look like this type. This is a spherometer. Here a linear scale is provided on which there are calibrations and reading markings, and this is the circular scale. This is the circular scale or the circular disc. This is the basically the schematic of a spherometer, and this is the rotating spindle. This is lead screw. This is the lead screw. And this is the central leg. This is the central leg. So if any curved surface you want to measure, you have to just put this spherometer on this curved surface. Okay, na? And by rotating this spindle, we can adjust this the height of the leg so that equal pressure act on the 3 points. Almost equal pressure act on the three legs, and depending upon the reading of the scale where these points coincide, we can measure the thickness of the plate or the curvature of the plate, whatever the physical parameter is given. So this particular device is used for measuring the length part, the dimension, that is length. So in this particular case, you can see that this is the length dimension, this is the length dimension, and this is the length dimension. A specific rotation of liquid, this is a parameter, something which is related to optical quantity. It is measured using polarizer and analyzer. Polarizer and analyzer. It is basically made using polarizer and analyzer. Okay, na? This is optical parameter of the liquid. It has nothing to do with a spherometer. So the correct option for this particular case is option number 2. Sorry, option number 2, because they have asked what cannot be measured using a spherometer. So the correct option is option number 2. Now, question number 9, two bodies of mass 4 gram and 25 gram are moving with equal kinetic energies. The ratio of magnitude of the linear momentum. Ratio of magnitude of linear momentum, it's a very simple question. We know that momentum is related by kinetic energy according to the formula 2mke, where ke is the kinetic energy, p is the linear momentum. So the mass, the kinetic energies are equal. The kinetic energies are equal, it is said in the question. So p is directly proportional to root m. It is directly proportional to square root of mass of the particle. So if I denote that first particle and this as the second particle, then we can write P1 by P2 is equal to square root of M1 by square root of M2. Now M1 is 4 gram and this is 25 gram. So simple, P1 by P2 is equal to 2:5. So the correct option is the ratio of linear momentum is 2:5. The ratio of linear momentum is 2:5. If the masses are different but kinetic energy is the same, then the ratio of linear momentum will be simply the square root of the masses. Next, coming to question number 10. 0.08 kg of air is heated at constant volume. The heating is being done in a constant volume process. It is an isochoric process. Isochoric process. Through 5 degrees Celsius. The gas has been heated by 5 degrees Celsius. Okay. The specific heat of air at constant volume is 0.17 kilocalorie kg. And J, mechanical equivalent of heat, J is joules constant, is given as J equal to 4 joule per calorie. The change in its internal energy. See, the internal energy change is given by mCV delta T. In case of ideal gas, we know that the internal energy change is just a function of temperature. So whatever be the process, it doesn't matter whether it is a constant volume process or a constant pressure process or adiabatic process, whatever the thermodynamic process is given in the problem, as far as ideal gas is concerned, the internal energy change will be given by this formula, that is mCv delta T. So here 0.08 we can substitute 0.08. Cv is given in the form of kilocalorie per kg degree Celsius. So 0.17 kilocalorie per kg degree Celsius. And this is here, I can write it like this, 0.08 kg. And delta T is 5 degrees Celsius, okay. So if we just look at the unit, this kg and this kg cancels out. This degree Celsius cancels out. Kilocalorie, in terms, the answer will be coming in terms of kilocalorie. So, but the options are given in terms of joules. So what do we have to do? We have to multiply with the J. And the J is nothing but 4.18 joule per calorie. It is joule per calorie. So here we can see that this calorie and this calorie will cancel out, but here will be 1000 because it is kilocalorie. So multiplying all this factor, we can say that the answer will be 0.08 into 0.17 into 5 into 4.18 into 1000. So this 88 into 1.7 into 5 into 4.18, 44 into 17, we can take this as 4.2, 68 into 42 by 10. So we can 68 into 42, 8 to the 16, 6 to the 12, like 13, 32, 3, 27, 6, 3, 5, 8, 285.6. So the correct answer will be 284. Because we have approximated that 4.1, it has 4.2. So the correct option will be 284 joule. So this is the correct option for this particular question. Now coming on to next question, question number 11. The radius of third stationary orbit. This question is related from modern physics chapter. The radius of third stationary orbit, of electron for Bohr's atom is R. This capital R is the radius of third stationary orbit. The radius of fourth stationary orbit. Third orbit का radius दिया हुआ है आपको R के term में, and they have asked the radius of the fourth stationary orbit. It's a very simple question. We already know that radius of nth orbit is given by 0.529 n square upon z, where z is the atomic number, n is the number of orbit in which the radius has to be calculated, and 0.529 is the constant, and this answer comes out to be in angstrom. So here we can see that R is directly proportional to n square, simple, because these two things are constant. So if we use this, R is directly proportional to n square, so R3 by R4 is equal to n3 square by n4 square. Third orbit means 9, 4 orbit means 16, and R3 is given as R, so R4 will be 16 by 9 times R. So the fourth orbit radius will be 16 by 9 times R. As we can see that option 2 is matching with our calculation. So the correct answer for this particular question is option number B, which is 16 by 9 times into R. A very simple question based on the atomic radius. Now coming to question number 12. Question number 12 is based on the magnetic flux, Faraday's laws of electromagnetic induction. A rectangular loop of length 2.5 meter and width 2 meter is placed at 60 degree to a magnetic field of 4 Tesla. एक rectangular loop की बात की जा रही है, एक rectangular loop की बात की जा रही है कि this is the rectangular loop जिसका dimension दे रखा है 2.5 मीटर वाइड है, लेंथ में है, और 2 मीटर विड्थ में है, ठीक है. And the loop is placed at 60 degree to the magnetic field. The loop is removed from the field in 10 seconds. The average EMF induced in the loop is. तो अगर इस loop को थोड़ा हम tilt करके बनाएं, so this will be the situation. This will be the situation कि ये loop है. Let's suppose this is 2 meter and this is 2.5 meter. So the area vector will be outward normal, A vector, and this is, let's suppose, the magnetic field B vector, and the angle is theta equal to 60 degrees. That's what they are saying in the question. So this is the particular situation. Now the loop is suddenly removed from this magnetic field. So in this particular case, when the loop is present inside the magnetic field, the flux will be simply BA cos theta. B dot A, we know that the flux is given by B dot A dot product of B and area. If magnetic field is constant and uniform, then we can take the magnetic field out of the integral sign. So it will simply a dot product of two vectors, BA cos theta. So magnetic field, the value of magnetic field is 4 Tesla. Area of loop will be 2 into 2.5 means 5 meter square. And cos theta, cos 60 degree, it will be 1 by 2. So 2 2s are 4, 5 2s are 10 Weber or Tesla meter square, what we can say. Now when the entire loop is removed from the magnetic field as they are saying, so the flux will be 0. Phi 2 will be 0, obviously, because there is no magnetic field at all. So the flux will be 0. So initial flux is 10, final flux is 0. So induced EMF as per Faraday law will be minus delta phi by delta t. Minus of final flux is 0, initial flux is 10, and delta t is in 10 seconds. The time is given 10 seconds. So this will be plus 1 volt. Most of the time, what students commit the mistake is that they don't take this change as negative, because actual formula is E induced equals to minus d phi by dt. So this is the change. So you have to do final minus initial. And there is a minus sign already because it has to be inconsistent with the Lenz's law. So this final flux is 0 and initial flux is 10. So you have to use 0 minus 10, and that minus and minus will automatically make it plus. So the correct option will be plus 1 volt and not this minus 1 volt. So those who have marked minus 1 volt, that unfortunately the answer is not correct. So the correct option is plus 1 volt. Now coming to question number 13. Question number 13 is based on a very basic concept of electric potential. What they are saying that an electric charge of 10 raised to the power minus 6 microcoulomb is placed at origin of the XY plane. Very good. Let's draw the XY plane. I'm drawing over here the XY plane. This is the XY plane, and this is the origin. Here, a charge of 10 raised to the power minus 6 microcoulomb is placed at the origin. 2 points, they are talking about 2 points, points P and Q. 2 points taken in this plane. One is at root 3, comma root 3, and other is at root 6, comma 0. So root 3, comma root 3 point will be definitely in the first quadrant, and this is point P, and point Q will be root 6, comma 0. That will be on x-axis because y coordinate is 0. So if you look at these 2 points, then this distance, this is O, and OP. OP will be equal to root 6 because from the distance formula, root 3 minus 0 whole square, root 3 minus 0 whole square square root, it will come out to be root 6, and this distance is also root 6. Now we know that if there is a point charge Q and at a distance R, the value of potential is given by KQ by R. K is nothing but 1 upon 4 pi epsilon naught Q upon R. As you can see that potential is depending on the distance R. Since in both the cases this R and this R are same, so potential at P will be equal to potential at Q for this particular problem. So the potential difference means Vp minus Vq, what they are asking. The difference will be definitely 0, no need to calculate because the distance of both the points are same. So potential of both the points are same, hence potential difference will be 0. So the correct answer for this particular question is option number 3. Both the points are at same potential, it's just an equipotential point you can say, and the potential difference will be 0. Now coming to question number 14, a convex lens of focal length 40 centimeter forms an image of an extended source of light on a photoelectric cell. एक photoelectric cell की चर्चा की गई है इस particular question में, ठीक है? A current I is produced, current I दे रखा है, ठीक है साहब? The lens is replaced by another convex lens having the same diameter. This is a very important part that they have informed. Diameter means beta aperture. Aperture of the lens they are talking about. This is not the radius of curvature, not to confuse with the radius of curvature of the lens. Radius of curvature is different thing. The diameter means aperture of the lens, the circular boundary of focal length 20 centimeter. In the first case, the focal length is 40, and the second case, the focal length is 20. Okay, this is the focal length, initial focal length. What will be the photo current in terms of I? It's a simple question based on photo current. So I am drawing the two lenses over here. This lens is of focal length 40 centimeter, and this lens is of focal length 20 centimeter. Okay. And let's suppose I have kept a photo cell over here. This is our photo cell. and this is again the photocell at same location for second lens. In both the cases, parallel beam of light is coming. Okay, here also parallel beam of light is coming. So as you can see that after the convergence, it will fall on the photocell. Depending upon where the focal point is, the light rays will converge at that point. That is not the issue. What main thing is that in the question, this diameter aperture of the lens is same, mean the size of the lens is same. So number of photons that will be striking the convex lens will be same in both the cases. So same number of photons will strike the photocell over here as well as over here. The area of impingement of the photons will be same for both the cases. So the photocurrent will be same. Photocurrent will be same. Photocurrent won't change. Photocurrent will be same. Changing the focal length has nothing to do with the photocurrent, because it just depends upon whether the light beam will converge. It may converge before, it may converge after. That is another issue. The number of photons that will striking this photocell will be same in both the cases. So there is no change in photocurrent. The energy incident on this photocell is same. So the current will be still I. What the initial current is given, the same current will be in second case also. So the correct option is option number 4. Now coming to next question, question number 15, we can see what is given. A body of mass 100 kg is moving horizontally with velocity of 6 meters per second. Okay. If 200 kg extra mass is gently added, the final velocity is. This is a very basic question of conservation of linear momentum. Very, very basic question on conservation of linear momentum. Let's suppose this is a body of mass 100 kg. And it is moving with a velocity of v1 equal to, let's suppose, 6 meters per second. That is given in the question. Now, in the second situation, what they have done in the second situation, on this body, another body is kept whose mass is 200 kg. It's 200 kg mass body and it is 100 kg mass body, and now they are moving with velocity v2, and this v2 has to be evaluated. It's a very simple question. When we put some mass on the 100 kg block, it's a gently, then whatever force of impact will exist, that will be the internal forces. So in horizontal direction, there is no net force, so the momentum is conserved. So initial momentum m1 v1 is equal to final momentum m2 v2. Initial mass is 100 kg, initial velocity is 6, final mass is 300 kg, and final velocity they have asked 100,332. So v2 will be equal to 2 meters per second. So the correct option is option number 2. A very basic question on linear momentum that the JEE Mains NT has asked this in this particular session. Now coming to question number 16. A plane electromagnetic wave. This question is based on EM wave from modern physics part. A plane electromagnetic wave propagating in x direction is described by EY equal to 200 volt. This is the wave electric field component of the EM wave. This entire expression. This is the electric field amplitude E0. This is sine omega t. Omega t is the 2 over 1.5 into 10 raised to the power 7. This is the angular frequency of the wave. This is the time, and this is the wave number kx. The intensity of wave, use epsilon naught. This value has already given. It's a very simple question. Intensity is, we already know that half epsilon naught E0 square c. This is the expression. Now this particular question is entirely based on this formula. The student who will be remembering this formula on the day of exam, they will be able to crack this question. It's a simple subput and get type of question. Now half epsilon naught E0 square c. So E0 is given. This is E0 amplitude of electric field. So half into epsilon naught value, they are taking 8.85 into 10 raised to the power minus 12. E0 200 into 200, and speed of light is 3 into 10 raised to the power 8. This is the universal constant that we can see. If we calculate all this parameter, what we will be getting is option number 2, that is 553.1 watt per meter square. This is the intensity that we can calculate. Simple put and get type of question. This was on EM wave. So this is the correct solution. So the correct answer is option number 2, 53.1 watt per meter square. Coming to question number 17, this is again statement based question. Planck's constant, statement 1, what they are saying that in statement 1, Planck's constant and angular momentum have same dimension. So Planck's constant h, it is nothing but energy into time. Energy into time. So if dimension of Planck's constant, if we write, that is ml square t minus 2 into t, and it will come out to be ml square t minus 1. And angular momentum. Angular momentum L vector. That is R cross P vector. So dimension of angular momentum, if we calculate, dimension of this is the position vector, it will be having the dimension of length L, and the momentum is mass m lt minus 1. So ml square t minus 1. So from these two expression you can see, ml square t minus 1, ml square t minus 1, both are having the same dimension. So this is absolutely correct. This is true. Also you can see that angular momentum L vector barabar nh upon 2 pi. This is the Bohr's postulate. So n and 2 pi are non-dimensional numbers. So quite obvious is that angular momentum will be having same dimension of Planck's constant. So Planck's constant and angular momentum have same dimension. This is true. Linear momentum and moment of a force. Moment of a force is nothing but this is torque. This is torque. Linear momentum, dimension of linear momentum P will be equal to m lt minus 1. And the moment of force torque dimension we can have Newton meter m lt minus 2 L, which will be equal to ml square t minus 2. As you can see, both are not at all matching, and it's obvious that both are having different quantities, so they will be having different dimensions. So statement 2, this is false. Statement 2 is false. So from the given option, we can say the statement 1 is true, but the statement 2 is false. So the correct option for this question is option number 1. Now moving on to next question, question number 18. A wire of length 10 centimeter and radius root 7 into 10 raised to the power 4 minus 4 meter connected across the right gap of a meter bridge. When a resistance of 4.5, this question is based on meter bridge. When a resistance of 4.5 ohm is connected on the left gap by using a resistance box, the balance length is found to be at 60 centimeter. Okay, this is the null point. The location of the null point is given from the left hand. If the resistivity of the wire is expressed as R into 10 raised to the power minus 7 ohms meter, then the value of R is. It's a very basic question of meter bridge. If I draw a meter bridge, then it will appear like this. This is one resistance. This is second resistance. And the null point is here, what they are giving. This is galvanometer. So this is 60 centimeter from left end, and so the remaining will be 40 centimeter because this wire length is 1 meter because it is based on meter bridge. Now here the resistance is 4.5 ohm in the left gap, and in the right gap let the resistance be R. Okay, so for the balance bridge condition, we already know that the current through galvanometer will be 0. Only then the bridge will be balanced. So if the current through the galvanometer is 0, this is the null point, NP. So what we can say is that from balance bridge condition, 4.5 upon 60 will be equal to R upon 40. And calculating here, we can get 4.5 into 40 by 60, and this will be equal to 3 ohms. So this particular resistance in the right gap is 3 ohm. The resistance in the right gap is 3 ohms. Now the resistance is known. What we have to do? We have to calculate the resistivity. So we know that the resistance R is related by rho L upon A. So resistance is 3 ohm. Resistivity they have asked. Length of the wire is given as 10 centimeter, means 0.1. And radius pi R square. R is root 7 into 10 raised to the power 4. So 7 into 10 raised to the power minus 8. So if we will solve this, we will be getting rho equal to 3 into pi. We can write 22 by 7 into 7 into 10 raised to the power 8 into 10. And here we will be getting 66 into 10 raised to the power minus 7 ohm meter. So if we compare the given situation, this value and the value that which we are getting, so this particular is R, 66, because the next term is 10 raised to the power minus 7. We also get 10 raised to the power minus 7. So the multiple is it's a multiple of 66. So the correct option is option number 3. Moving on to question number 19. A wire of resistance R is cut into 5 equal parts. If these parts are joined parallelly, then the resultant resistance will be. Very basic question from electrical circuits of combination of resistance. This is a resistance of resistance R. Let's suppose its length is L and cross section area is A. Now this wire is cut into 5 equal parts. First part, second part, third part, fourth part, fifth part. So, but natural, if it is being cut into 5 equal parts, so each part will be having length of L by 5. Each part will be having length of 5. Each part will be having length of 5. This is L by 5, this is L by 5, this is L by 5. Now, all these resistance are being connected in parallel. First resistance, now second resistance, now third resistance, and so on. So, simple equivalent resistance in parallel will be 1 by R equivalent equal to 1 by R plus 1 by R plus up to 1 by R 5 times, which will be equal to 5 by R. And each resistance length has been 1 by 5 reduced by 5 times. So, rho L by 5A. So, it will be R by 5 times. The resistance has been reduced by R by 5 times. So, here will be 5 by R into 5, which will be 25 by R. So, R equivalent will be R upon 25. So, the correct option is option number 1. Very basic question that we used to study. This kind of questions were asked in class 10th exams also. Now, question number 20. The average kinetic energy of a monoatomic molecule is 0.414 electron volt at temperature. They are asking about the temperature at which the monoatomic gas molecule will be having this kind of average kinetic energy. So, we already know that average kinetic energy per molecule is given by 3 by 2 kBT, where kB is the Boltzmann constant and T is the absolute temperature. So, this temperature they are asking in the question, and the energy is given in the terms of 0.414 electron volt. Now, first we have to convert electron volt into joule. We know that 1 electron volt is equal to 1.6 into 10 raised to the power minus 19 joule. So, we have to use this particular conversion factor in this question, only then the answer will be coming in Kelvin. So, using this relation 0.414 into 1.6 into 10 raised to the power minus 19, 3 by 2 we can write 1.5. The value of kB they have provided in the question 1.38 into 10 raised to the power minus 23 and T. So, if we calculate all these parameters, so here we will be T we will be getting as 3200 Kelvin. So, this answer is the answer of temperature that we are getting. So, the correct option is 3200 Kelvin. At 3200 Kelvin, the temperature of the gas molecule, the energy of the gas molecule will be 0.41 for average energy of a molecule, which depends only on temperature. Okay, now moving to next question. So, section A is completed. Now, we will be doing the solution of section B. This is a numerical answer type question. So, here we have to solve the question and write the answer in the given space. So, the first question of section B is a particle starts from origin at t equal to 0 with a velocity of 5 I cap meter per second and moves in xy plane under action of a force which produces a constant acceleration of 3 I cap plus 2 j cap meter per second square. If the x coordinate of the particle at that instant is 84 meter, then the speed of the particle at this time is root alpha meter per second. The value of alpha is. ये जो क्वेश्चन है वो काइनेमैटिक्स पर बेस्ड है, ठीक है, 2D मोशन का क्वेश्चन है, बहुत बेसिक क्वेश्चन है. तो इसको सॉल्व करते हैं. पार्टिकल का जो एक्सेलरेशन दिया हुआ है वो दिया हुआ है 3i कैप प्लस 2j कैप, ठीक है. तो यहाँ से पार्टिकल का जो एक्सेलरेशन का x कंपोनेंट है वो 3 मीटर पर सेकेंड स्क्वायर है और पार्टिकल के एक्सेलरेशन का जो y कंपोनेंट है वो 2 मीटर पर सेकेंड स्क्वायर है. ये कांस्टेंट एक्सेलरेशन वेक्टर है. पार्टिकल इज मूविंग विद कांस्टेंट एक्सेलरेशन ऑन xy प्लेन, ठीक है. अब क्वेश्चन में कहा गया है कि t इक्वल टू 0 पर जो वेलोसिटी है पार्टिकल की दैट इज 5i कैप. t इक्वल टू 0 पे जो वेलोसिटी वेक्टर पार्टिकल की दी हुई है, इनिशियल वेलोसिटी वेक्टर की अगर बात करें तो दैट इज 5i कैप मीटर पर सेकेंड, ठीक है. मतलब पार्टिकल सिर्फ एक्स एक्सिस की तरफ ही चल रहा है उस पर्टिकुलर सिचुएशन पे, इनिशियल इंस्टेंट पे. अब इन्हीं इंफॉर्मेशन को यूज करके हम लोग बनाएंगे. तो अगर हम लोग किसी टाइम टी की बात करें जहां पर इसका कोऑर्डिनेट कुछ टाइम के बाद 84 मीटर हो गया है, ठीक है, कुछ टाइम के बाद टी टाइम के बाद फाइनल एक्स कोऑर्डिनेट 84 दिया हुआ है. तो अगर एक्स टी मोशन की बात करें, एक्स डायरेक्शन के मोशन की बात करें तो एक्स टी बराबर x0 प्लस वी एक्स जीरो टी प्लस हाफ ए एक्स टी स्क्वायर, ठीक है ना. तो फाइनल एक्स कोऑर्डिनेट है 84, ठीक है. इनिशियल एक्स कोऑर्डिनेट 0 है क्योंकि पार्टिकल ओरिजिन से चलना शुरू किया है, ठीक है. इनिशियल वेलोसिटी का एक वेलोसिटी कंपोनेंट दैट इज 5, ठीक है. टाइम हमें नहीं पता, वो हमें निकालना है. एक्सेलरेशन है ax इक्वल्स टू 3t स्क्वायर, ठीक है. तो नाउ दिस इज अ क्वाड्रेटिक इक्वेशन. इसको सॉल्व करके t के 2 रूट्स आएंगे, उसी को हम लोग को सॉल्व कर लेना है. तो अगर हम लोग 2 से मल्टीप्लाई कर दें बोथ साइड्स, 4 2 ज़ा 8, 8 2 ज़ा 16 इक्वल टू 10t प्लस 3t स्क्वायर। ठीक है, तो यहाँ से हमारा आ जाएगा 3t स्क्वायर प्लस 10t माइनस 168 इक्वल टू 0। अब इस क्वाड्रेटिक के जो सॉल्यूशन होगा वही फाइनल टाइम इंस्टेंट होगा। तो इसको सॉल्व करें अगर इस पर्टिकुलर क्वाड्रेटिक इक्वेशन को, तो क्वाड्रेटिक सॉल्यूशन हो जाएगा t इक्वल टू माइनस बी प्लस रूट ओवर, माइनस वाला केस लेंगे नहीं क्योंकि टाइम नेगेटिव हो नहीं सकता, बी स्क्वायर 100 माइनस 4 इंटू 3 इंटू माइनस 168 रूट अपॉन 2a 6 माइनस 10 प्लस अंडर रूट 100 प्लस 12 इंटू 168। तो 168 को 12 से मल्टीप्लाई करेंगे, 8 2 16 33 एंड 168 6 11 2016 बाई बी स्क्वायर माइनस 400 अपॉन 6। तो ये जो आ जाएगा दिस विल बी द स्क्वायर रूट ऑफ 46। ये जो टर्म है वो 46 का स्क्वायर रूट हो जाएगा अपॉन 6। तो यहाँ से टाइम आ जाएगा 6 सेकेंड, टाइम आ जाएगा 6 सेकेंड। तो मतलब 6 सेकेंड के बाद पार्टिकल का जो एक्स कोऑर्डिनेट है वो 84 मीटर हो चुका है। तो हम लोग को फाइनल टाइम पता चल चुका है। तो अगर फाइनल टाइम हम लोग को पता चल चुका है, फाइनल टाइम अगर पता चल चुका है, तो नाउ स्पीड की अगर बात करें, फाइनल स्पीड वी एक्स टी बराबर वी एक्स जीरो प्लस ए एक्स टी। तो इनिशियल स्पीड है 5, एक्सेलरेशन का एक्स कॉम्पोनेंट है 3 और टाइम है 6। तो ये 23 मीटर पर सेकेंड हो जाएगा 6 सेकेंड पर वेलोसिटी का एक्स कॉम्पोनेंट। ठीक है, उसी तरह 6 सेकेंड पे वेलोसिटी का वाई कॉम्पोनेंट की बात करें तो वी वाई जीरो प्लस ए वाई टी। ठीक है, फर्स्ट इक्वेशन ऑफ मोशन। तो वी वाई जीरो जो हो जाएगा वो आपका गिवन है 0 क्योंकि पार्टिकल का इनिशियल वेलोसिटी एक्स डायरेक्शन में है, पार्टिकल इज नॉट मूविंग अलोंग वाई डायरेक्शन, मतलब t इक्वल टू 0 पे पार्टिकल वाई में मूव ही नहीं कर रहा है। तो वी वाई जीरो हो जाएगा। ए वाई की अगर बात करें तो वो 2 है और 6, तो ये 12 मीटर पर सेकेंड। तो पार्टिकल का इनिशियल वेलोसिटी है 23 एक्स के डायरेक्शन में, सॉरी टी टाइम पर 6 सेकेंड के बाद, और 6 सेकेंड के बाद वाई में जो वेलोसिटी है 12 मीटर पर सेकेंड। तो टोटल वेलोसिटी जो 6 सेकेंड पर होगी, पार्टिकल की टोटल वेलोसिटी जो होगी, वेलोसिटी एट टी इक्वल टू 6 सेकेंड, दैट विल बी अंडर रूट ऑफ 23 स्क्वायर प्लस 12 स्क्वायर। ठीक है ना, तो ये हो जाएगा आपको जाकर 529 प्लस 144 और ये हो जाएगा 673। तो रूट 673। तो अब क्वेश्चन में जो एक्सप्रेशन दिया गया है वो रूट अल्फा, इसका मतलब है कि अल्फा की वैल्यू हो जाएगी 673। तो इस पर्टिकुलर क्वेश्चन को जो करेक्ट आंसर है वो है 673। क्वेश्चन नंबर 22। A thin metallic wire having cross-sectional area of 10 raised to the power minus 4 meter square is used to make a ring of radius 30 centimeter. A positive charge of 2 pi coulomb is uniformly distributed over the ring, while another positive point charge 30 picocoulomb is kept at the center. The tension in the ring is, electrostatic tension का ये सवाल है, electrostatic tension का ये सवाल है कि एक रिंग की बात कर रहे हैं, they are talking about a ring, and on that ring a charge is given, positive charge 2 pi coulomb. Positive charge is uniformly distributed on this ring whose value is 2 pi coulomb. So Q is 2 pi and at the center they have kept another point charge 30 picocoulomb, small q, this is 30 picocoulomb. Now the radius of this particular ring is 30 centimeter. This is 30 centimeter is the radius. So they are asking what is the tension. First of all, we have to know that why tension will generate. See, this ring is completely charged uniformly over its periphery, so it will try to repel. It will try to repel and its radius will try to increase. Now this repulsion, this expansion will be resisted by the coulombic force that will be existing between this point charge and the ring. So this particular case in which the expansion of the ring is resisted by this Coulomb force, that will generate a tension in the material of the ring, and that tension we have to calculate. Okay, no issue. So first we calculate the lambda. Lambda will be Q upon 2 pi r, linear charge density of this ring, and that will be equal to Q is 2 pi, and this is 2 pi r. So 2 pi cancels out, 1 upon r. So this is Coulomb meter inverse. Equation 1, this is the lambda of the ring. Now, what we have to do, we have to calculate, we have to draw a free body diagram, this particular question. Okay, what we do, we draw a free body diagram. This is the ring. And we take any 2 points, A and B, which are very close to each other. This is a very close points. Point A and point B are very close to each other. Just to, for the clarity and for proper understanding, I am drawing it a bit far away. So if we join these 2 points with the center, this is the center where the point charge Q is placed, and this angle, let's suppose this angle is d theta, very small angle. So this particular length will be r d theta. This particular length will be r d theta. This particular length will be r d theta. Now, I am drawing this part again over here, part AB only. This is part AB. This is part AB of the ring. So, and this is the center. So this is the tension that we are required to calculate, and this point charge and this whole ring will generate a Coulombic force F. Let me draw a little bit here. So this F force is arising due to the repulsion between this point charge small q and the differential charge that is being provided in this particular length only. So this will be dq equal to lambda r d theta. Lambda is 1 upon r d theta. It will be simply d theta. Now if we resolve these two forces, this will be d theta by 2, and this will be again d theta by 2. So this angle will be d theta by 2. So this force will be having 2 components. One, this will be t sine d theta by 2, and this will be t cos d theta by 2. Here also there will be 2 components. This will be t sine d theta by 2. This will be t cos d theta by 2. As you can see, that horizontal component of the tension will cancel out, but what will remain is the vertical component, that is t sine d theta by 2 and t sine d theta by 2. These 2 components will be in downward direction, and they will add each other, and they will be opposed by this Coulombic force F. So the equilibrium condition will be F equal to t sine theta d theta by 2 into 2. So again writing the equation, we can write that F will be equal to 2t sine d theta by 2. Now since this angle is already very small, d theta is already very small angle, so d theta by 2 is again very small. So the sine terms can be neglected, can be removed, because we know that sine theta is equal to theta if theta is very, very small. This limitation we already know. So F is nothing but 2t d theta by 2. So 2t will be cancelled out. It will be simply t into d theta. Now what we have to do, we have to write F in terms of d theta. So what F will be? F is the force between this point charge and this charge, Q and dq. So F we can write, I am writing over here due to space constraint. So F will be k q dq by, now the separation is r square, q dq, this is dq, and dq is what? Is simply equal to d theta. So it is k q d theta upon r square. dq is equal to d theta. So now we will substitute here k q d theta by r square, k q d theta by r square. D theta will cancel out. Simply the tension will be k q by r square. So the simple expression for tension is k q by r square. Now k is what? K, the value of k is given, Coulomb's constant, 9 into 10 raised to the power 9. What is q? The charge q is given 30 picocoulomb, means 30 into 10 raised to the power minus 12 coulomb. And what is r? R is 30 centimeter, means 0.3 meter. So 0.3 into 0.3. So just we have to solve. So here we can see that 9 into 10 ke power 9. 9 into 10 raised to the power 9 into 30 into 10 raised to the power minus 12. And here will be 9 and here will be 100. So this 9 cancels out. And 9 plus 2, 11, 30. 3 Newton. So the tension that will be generating in the ring will be 3 Newton. So the here answer will be simply 3. Now coming to question number 23, sorry. Two coils have mutual inductance. Now this question is based on mutual inductance of two coils. Two coils have mutual inductance 0.02 Henry. The value of mutual inductance M is given. The current changes in the first coil according to the relation I equal to I naught sine omega t. The value of I naught and value of omega is already given in the problem. The maximum value of EMF in the coil is pi by alpha volt. What is alpha? It's very simple question. Two coils they're asking about. Let's draw two coils. This is coil 1 and this is coil 2. Their mutual inductance means M12 is given as 0.002 Henry. This is the mutual inductance of the two coils. They are given in the question. Now the current in the first coil, let's suppose this is the current in the first coil. It is given as I naught sine omega t. Okay. In case of mutual inductance, we know that the EMF is induced in the second coil when the current changes in the first coil. So we can write, if this is the flux associated with the second coil, so we can write like this as phi 2 equal to M12 I1. This is the basic equation relating with the mutual inductance, flux in the second coil, current in the first coil. ठीक है ना? Mutual inductance और self inductance में ये difference है. Self inductance में खुद में ही EMF induce होता है due to the change in the current itself. But mutual inductance में दूसरे coil में EMF induce होगा due to current in the first coil. ठीक है ना? तो phi 2 की वैल्यू अगर हम लोग देखें M12 I1 की वैल्यू हम लोग लिख लेंगे M इंटू आई नॉट साइन ओमेगा टी. ये बेसिक इक्वेशन बन के आता है फ्लक्स और करंट का. अब इसको कुछ नहीं करना है, जस्ट वी हैव टू डिफरेंशिएट दिस पर्टिकुलर इक्वेशन. वी हैव टू डिफरेंशिएट दिस पर्टिकुलर इक्वेशन. डी फाई 2 बाई डी टी विल बी इक्वल टू एम आई नॉट ओमेगा cos omega t. M I naught omega cos omega t. Now from Faraday law, this is nothing but this is a rate of change of flux in the second coil. So this is nothing but EMF induced. So E induced will be mutual inductance I naught omega cos omega t. और ये जो पर्टिकुलर वैल्यू है द cos omega t का जो आर्ग्यूमेंट है, जो सॉरी मल्टीपल है, कोफिशिएंट है. नाउ दिस विल बी द मैक्सिमम EMF इंड्यूस्ड, क्योंकि इसकी मैक्सिमम वैल्यू 1 हो सकती है. सो द मैक्सिमम EMF इंड्यूस्ड विल बी M I naught omega. M I naught omega will be the maximum EMF induced. तो अगर मैक्सिमम EMF इंड्यूस की बात करें, E इंड्यूस्ड मैक्सिमम की अगर बात करें, देन इट विल बी M I naught ओमेगा. M की वैल्यू है 0.002, I naught की वैल्यू दे रखी है 5 और ओमेगा की वैल्यू दे रखी है 50 पाई. सो इसको 2 बाई 1000 कर देते हैं, ये 250 हो जाएगा और ये पाई हो गया. तो ये कैंसिल आउट, ये 4 से 2, तो ये कितना आ गया पाई बाई 2. अब इफ यू कंपेयर दिस पर्टिकुलर एक्सप्रेशन विद द गिवन ओवर हियर, तो पाई तो हमारा भी ऊपर में न्यूमरेटर आ रहा है, तो नीचे क्या है 2. तो करेक्ट ऑप्शन जो यहां पर होगा दैट विल बी 2. क्वेश्चन नंबर 24. हाँ, दिस इज द क्वेश्चन ऑफ ऑप्टिकल रिफ्रैक्टिव इंडेक्स एपरेंट डेप्थ का ये क्वेश्चन है. ये क्वेश्चन बहुत सिंपल क्वेश्चन है. 2 लिक्विड को यूज किया गया है. एक बॉटम में एक कॉइन रखा गया, कॉइन इज प्लेस्ड ओवर हियर. एक बॉटम के टैंक के बॉटम में एक कॉइन है और 2 लिक्विड है. रिफ्रैक्टिव इंडेक्स 3/2, 8/5 और दोनों लिक्विड कॉलम का हाइट 6 सेंटीमीटर है. नियर नॉर्मल विजन में दे आर टेलिंग दैट 2 इमिसिबल लिक्विड ऑफ रिफ्रैक्टिव इंडेक्स 8/5 and 3/2 respectively are put in a beaker as shown in the figure. The height of each column is 6 centimeter. A coin is placed at the bottom of the beaker. For near normal vision, the apparent depth of the coin is alpha/4. The value of alpha is near normal का मतलब जो भी ऑब्जर्वर है, the observer is observing this coin perpendicularly from the tank. यहाँ पर अगर एक ऑब्जर्वर है जो इस कॉइन को देख रहा है, so he or she is looking perpendicularly from the surface of that liquid, top liquid. So आपको बताना, हम लोग को ये बताना है कि where this coin will be appear to him, कितना ऊपर उठा हुआ दिखेगा, what will be the apparent depth. ओके, एपरेंट डेप्थ की बात की है, एपरेंट शिफ्ट की बात नहीं की है. सबसे पहला क्वेश्चन जो माइंड में हम लोग को दिमाग में लाना है कि व्हेनेवर द क्वेश्चन ऑफ एपरेंट शिफ्ट या एपरेंट डेप्थ कम्स, देन यू हैव टू फर्स्ट सी दैट वेदर इन द क्वेश्चन दे आर आस्किंग एपरेंट शिफ्ट और एपरेंट डेप्थ. अगर एपरेंट शिफ्ट की बात करेंगे तो देन इट विल बी मेजर्ड फ्रॉम द बॉटम सर्फेस, और अगर एपरेंट डेप्थ की बात करेंगे देन इट विल मेजर फ्रॉम द टॉप सर्फेस. तो अगर नाउ लेट्स यूज दिस पर्टिकुलर डायग्राम इटसेल्फ. फॉर फर्स्ट रिफ्रैक्शन, लेट्स सपोज दैट द कॉइन इज हियर. फर्स्ट रिफ्रैक्शन, coin यहाँ पर आया, just refraction by this liquid column, this liquid column having refractive index 8/5. So इस distance को मैं mark कर देता हूँ. Let's suppose this is x. This distance is x, which is measured from the interface of the second and the first liquid. So we can write x upon original depth 6 centimeter. Light is going into 3/2 medium, 3/2, and light is coming from 8/5. So this will be 3/2 into 5/8, 15/16. So x will be equal to 6 into 15/16, 45/8 centimeter. So the coin will be at a height of 45/8 centimeter from second interface. Now again refraction, this particular image formed by the refraction of bottom liquid will act as a virtual object for second refraction, and final image will be formed then. So we will use this particular case. Now refraction through top liquid. Let's suppose that refraction through top liquid, the final image is being formed over here, somewhere here. Let's suppose the final image is formed somewhere here, and this is y, and this is y. So what will be the y? By, from this the depth is 6 plus x, x plus 6. Light is going into air, this is air, so refractive index is 1, and it is coming from 3/2, means 2/3. So y will be 2/3 into x plus 6, 2/3. Now value of x that we have calculated is 45/8 plus 6. It will be 2/3 into 48 plus 45. 48 plus 45, 90. 3/8, 2 4s are 8. 2 4s are 8. 3, 31/4. So if we compare our final answer with this particular expression, alpha/4, and we are getting 31/4. So 4 and 4 are same. So quite obvious is that the answer is 31. So for this particular question, the answer is 31. We have to analyze this particular problem in multiple refraction. 2 refractions will be taking place, first for bottom liquid, then for top liquid, and the final image will be formed after refraction from the top liquid. So the observer will be able to see at 31.4 meter, means from the top surface the image will be formed at 31/4 centimeter. Coming to question number 25. In a nuclear fission process, a high mass nuclide जिसका mass number A236 with binding energy 7.6 MeV per nucleon dissociated into middle mass nuclide 118, ठीक है, having binding energy 8.6 MeV. Okay, the energy released in the process is, if you analyze, this question is from nuclei chapter. If we analyze the binding energy per nucleon curve, here is the mass number A, and here binding energy per nucleon is in the y-axis. So if we analyze this graph, this will be for iron, most stable. So this right part is the fission part, and this is the fusion part. A heavy nuclei splits into 2 smaller nuclei in fission process, and fusion process, a smaller nuclei, 2 smaller nuclei will convert into a bigger nuclei. In both the cases, the binding energy per nucleon will increase, and that will be the Q value of the reaction. What is the energy released in the reaction? So here in this case, the mass number is given as 236, and here 2 nuclei are being formed having mass number 118. ठीक है, और दोनों की बाइंडिंग एनर्जी पर न्यूक्लियन दी हुई है, तो वी नो दैट एनर्जी इज बीइंग रिलीज्ड इन दिस प्रोसेस. इन दिस प्रोसेस एनर्जी इज बीइंग रिलीज्ड. In this process, energy is being released, and this particular energy is nothing but Q value of the reaction. So very important that if energy is released, then Q value of the reaction will be 2 into 118 into 8.6 minus 236 into 7.6. So this is 236, we take common. 8.6 minus 7.6. 236 into 1 equal to 236 MeV. So the correct option is 236 MeV. 236 MeV is the correct option. Now Now coming to question number 26. Coming to question number 26. 4 particles each of mass 1 kg are placed at 4 corners of a square of side 2 meter. Moment of inertia of the system about an axis perpendicular to its plane passing through one of its vertex. एक square frame दे रखा है. In this problem, a square frame is given, and there are 4 particles each having mass 1 kg. 1 kg, 1 kg. This is also 1 kg, and this is also 1 kg. And the dimension of the square and the dimension of the square is 2 meter. It's a 2 meter by 2 meter square. So it's a simple question. They are telling that we have to find the moment of inertia of this complete system of masses about an axis which is passing through one of its vertex and perpendicular to the plane of the figure. So this is the axis that they have shown schematic in the schematic diagram. About this axis we have to calculate. So it's very easy. If we can see that for this particular mass, the distance is 2 meter itself. For this particular mass, the distance is 2 meter itself. But for this mass, the distance is root 2 times into 2 meter. For this mass, the distance is root 2 times into 2 meter. So the moment of inertia will be 1 kg into 2 square mr square. We know that the moment of inertia, is mr square, and they are point masses. So nothing we have to do about. Just simply use this formula and add it, because moment of inertia is a scalar quantity. Calculating moment of inertia of each particle, and then we will be adding them. So 1 into 2 square plus second mass 1 into 2 square plus 1 into 2 root 2 whole square. So this is 2 to the 4, 4 plus 4 to the 8, 16 kilogram meter square. Simple question. So the answer will be 16 kilogram meter square. Now coming to question number 27. A particle executes simple harmonic motion with an amplitude of 4 centimeter. Okay. At the mean position, velocity of particle is 10 centimeter per second. The amplitude of SHM is given as 4 centimeter. The mean position, the velocity of particle is 10 centimeter per second. The distance of the particle from the mean position when its speed is 5 centimeter per second. Let's draw a schematic diagram. Let's suppose this is the mean position and this is the amplitude minus a and plus a. Now in the question that it is being said that the mean position, the velocity of particle is when the particle is at this position. When the particle is at this position, mean position, let's suppose its velocity is given as 10 centimeter per second. The distance of the particle from the mean position when its speed becomes 5 centimeter per second is. तो डिस्टेंस पार्टिकल का कैलकुलेट करना है उस इंस्टेंट पे जब मीन पोजीशन से उसकी डिस्टेंस 5 सेंटीमीटर अगर है, व्हेन द डिस्टेंस इज एट 5, व्हेन द पार्टिकल इज एट 5 सेंटीमीटर फ्रॉम द मीन पोजीशन, उस वक्त उसकी क्या डिस्टेंस होगी इज रूट अल्फा. ओके, एक्स और यहाँ पे उसकी वेलोसिटी 5 सेंटीमीटर पर सेकेंड दे रखी है. So we have to find the distance of the particle. It's very simple. In the question we know that the velocity of the particle is given by v barabar omega into under root a square minus x square. This is a very basic formula of linear SHM. The velocity of a particle is given by v equal to omega into a square minus x square, where x is the location of the particle measured from the mean position and v is the instantaneous speed at that particular location. So if we put here x equal to 0, because the mean position we have assumed at our origin, so in the question answer is the speed at mean position is 10 centimeter per second. So substituting here 10 omega into under root amplitude is 16, 4 ka square 16 minus 0. So this will be 10 equal to omega into 4. Omega will be 2.5 radian per second. So this is the omega. The angular frequency of the SHM is 2.5 radian per second that we have calculated. Now they are asking the distance. The distance from the mean position when the speed is 5 centimeter per second. Again we will be using this equation. And we will be calculating the distance. So now the velocity is becoming 5 centimeter per second. Omega is 2.5. Amplitude is 16 minus x square. If we square both sides, then we will be getting 25 equal to 2.5 square into 16 minus x square. So 16 minus x square will be 2.5. 5 by 2, 25 into 4 will be 4. And x square will be 16 minus 4 equal to 12. So x will be root 12. So the correct answer will be 12 centimeter, where alpha is 12. Alpha is 12. Because the distance is given in centimeters, root alpha, and we are getting 16 minus 4, 12. So inside the root we are having 12. So the correct answer is 12 for this very particular problem. Now coming to question number 28. Two long straight wires carry equal currents in opposite direction as shown in the figure. The separation between wires is 5 centimeter. Okay. The magnitude of magnetic field at point P midway between the wires. So this is a very basic problem of magnetic field due to infinitely long wire. These two wires are given and the separation between the wire is 5 centimeter and the separation between the wire is 5 centimeter. The magnitude of magnetic field at a point P midway. So this distance is from each wire will be 2.5 centimeter. The distance from each wire will be 2.5 centimeter. Now we can see if we use the palm rule or whatever we can use, right hand thumb rule, we can see that for the first wire, the left wire, the magnetic field is inside. And if we see the right wire, the magnetic field is also inside, because if we put our thumb, if we align our thumb in the direction of the current, magnetic field is going inside. So for both the wires, and since the current direction of current is opposite, so for both the wires, the magnetic field at the midpoint will be inside only. So net magnetic field will be add up. Now we know that if there is a long wire and any point P is situated at a distance of x from this wire carrying current I, so magnetic field strength is given by mu naught I upon 2 pi x. This is the expression for magnetic field due to infinitely long wire at a point P located at a distance x from the wire. Okay, so here we can see that the net magnetic field is being added. So the total magnetic field will be B equal to mu naught I upon 2 pi x plus mu naught I upon 2 pi x. So it will be 2 mu naught I upon 2 pi x, and 2 will cancel out. It will be mu naught I upon pi x. So here mu naught, the value of mu naught is separated by the distance etna. The value midpoint the wire is the magnitude of the magnetic field at a 4 pi into 10 raised to the power minus 7 is the value of mu naught. Current is given 10 ampere, pi and x. The distance x will be 2.5 centimeter, means 5 by 2 into 10 raised to the power minus 2 in terms of meter. So here pi will cancel out. 5 2s are 10, 2 2s are 4, 4 4s are 16. So 160 micro Tesla. So the correct option is 160 micro Tesla, because we will convert into Tesla, you have to multiply it with 10 to the power 6, and this 10 to the power 6 will be cancel out with this minus 7, and the answer will be 160. So the correct option is 160. Coming to question number 29, the charge accumulated on the capacitor connected in the following circuit is. इस पर्टिकुलर सर्किट में कैपेसिटर के अक्रॉस कितना चार्ज एक्यूमुलेट हुआ अंडर स्टेडी स्टेट. दिस इज अ वेरी इंपॉर्टेंट part that we have to use in this particular question, very important concept. Under steady state condition only we have to analyze this circuit, because it is RC circuit, resistance plus capacitor circuit. So in this particular case, under steady state condition means after very long time, you can say about 5 times the time constant of the capacitor will be fully charged, and it won't receive any further charge from the battery, any current from the battery. So this particular branch will be open circuit after infinite long time under steady state condition. I will write that under steady state condition. Under steady state condition. So if we redraw the circuit, this is a 10 volt battery, and here the circuit is open, because under a steady state the capacitor won't charge further, it has received maximum charge, and after that the circuit will be open. So here the resistance is 1 ohm, here the resistance is here the resistance is 6 ohm, here the resistance is 1 ohm, here the resistance is 2 ohm, here the resistance is 4 ohm, and here the battery is 10 volt. Now what we have to use is just simple. We have to see what is the potential. Let's suppose this is point A and this is point B. We have to just calculate the potential difference between these 2 points, and then we will apply the formula Q equal to CV to calculate the net charge accumulated. Okay. Now here this point will be at 10 volt and this point will be at 0 volt. If you see the equivalent, above two resistance are in series, so the 6 and 4 ohm, sorry, and this is 1 ohm and 6, this is 1 ohm, and that is 4 ohm and 2 ohm. Okay, now the above resistance is 10 and the voltage is 10 volt, so the current will be 1 ampere. The lower resistance is 3 and the voltage is 10, so this is 10 by 3 ampere. Here it is 10 volt. V equal, if the potential drop at A will be 6, here will be 4 volt. And if we see here, the IR 10 by 3 volt. So 10 minus 10 by 3, 20 by 3 volt. Here will be 20 by 3 volt and here will be 4 volt. So the potential difference is delta V across the capacitor is 20 by 3 minus 4. 4th is a 12, 8 by 3 volt. So the charge accumulated Q will be equal to CV. Capacitance 150 microfarad is given in the question. 150 into 8 by 3, 35, 400 microcoulomb. So the charge accumulated in the capacitor will be 400 microcoulomb. But this calculation is possible only when we assume that the capacitor is under steady state condition. The circuit is under steady state condition and not in the transient state. Coming to next question, this is the last question of section B. ठीक है ना? तो अब देखते हैं इसका solution क्या है question में कि if the average depth of ocean is 400 meter and the bulk modulus of water is 2 into 10 raised to the power 9 Pascal, then fractional compression delta V upon V of water at the bottom of ocean is alpha into 10 raised to the power minus 2. ठीक है, the value of alpha is, ये bulk modulus का question है, बहुत simple question है hydrostatic pressure के ऊपर. तो let us represent this question on a schematic diagram. एक ओशन की चर्चा की गई है, एक ओशन के बारे में कहा गया है क्वेश्चन में. लेट सपोज दिस इज अ ओशन और ये ओशन बेड है जो कि लेट सपोज क्वेश्चन में जो डेप्थ दी गई है h इक्वल टू 4000 मीटर का डेप्थ है क्वेश्चन में. ठीक है, और बल्क मॉडुलस ऑफ वाटर दिया हुआ, वाटर का बल्क मॉडुलस दे रखा है 2 इंटू 10 का पावर 9 पास्कल, 2 इंटू 10 रेज टू दी पावर 9 पास्कल का बल्क मॉडुलस है. ठीक है, तो कंप्रेशन की बात कर रहे हैं. तो अगर हम लोग एक पॉइंट यहाँ पर ले ले, लेट सपोज दिस इज पॉइंट 1 और एक पॉइंट ले ले पॉइंट 2. ठीक है, तो वी नो दैट फ्रॉम लॉ ऑफ हाइड्रोस्टैटिक दैट P2 इज इक्वल्स टू P1 प्लस रो GH. तो इंक्रीज इन प्रेशर P2 माइनस P1 विल बी रो GH. तो डेल्टा P जो हो जाएगा वो हो जाएगा रो GH, where rho is the density of ocean water. ठीक है ना, G is the acceleration due to gravity and H is the depth of the ocean which is given in the question. ठीक है, अब बल्क मॉड्यूलस का जो बेसिक डिफरेंस होता है, बल्क मॉड्यूलस का जो बेसिक डेफिनेशन होता है, बल्क मॉड्यूलस इज बेसिकली डिफाइंड एज K इक्वल टू चेंज इन प्रेशर, डायरेक्ट स्ट्रेस, नॉर्मल स्ट्रेस अपॉन वॉल्यूमेट्रिक स्ट्रेन, डेल्टा V अपॉन V. ये होता है बल्क मॉडुलस. ठीक है, रेशियो ऑफ डायरेक्ट स्ट्रेस अपॉन वॉल्यूमेट्रिक स्ट्रेन. ठीक है, तो डेल्टा P जो है दैट इज द चेंज इन प्रेशर. ठीक है, ये बोल भी रहे हैं कि बॉटम ऑफ द ओशन, फ्रैक्शनल कंप्रेशन बॉटम ऑफ द ओशन, मतलब सरफेस से बॉटम तक आने में जो फ्रैक्शनल कंप्रेशन होगा उसकी बात कर रहे हैं. तो डेल्टा P वी हैव कैलकुलेटेड रो GH और डेल्टा V बाई V निकालना है. तो डेल्टा V बाई V विल बी सिंपली डेल्टा P अपॉन K. ठीक है ना, डेल्टा P अपॉन K. तो इसको अगर हम लोग यहाँ पे सब्सटीट्यूट कर दें, डेल्टा V बाई V फ्रैक्शनल कंप्रेशन विल बी रो GH अपॉन K. ठीक है ना, अब सारी वैल्यूज को अगर सब्सटीट्यूट किया जाए इस पर्टिकुलर क्वेश्चन में तो हम लोग को आंसर मिल जाएगा. 1000 है डेंसिटी ऑफ वाटर, G की वैल्यू है 10, ठीक है, H की वैल्यू है 4000 और K की वैल्यू क्वेश्चन में दे रखी है 2 इंटू 10 रेज टू दी पावर 9. ठीक है, इसको अगर सॉल्व किया जाए तो 3 3 6 एक 7, ठीक है, और ये 2 2 तो 2 इंटू 10 का पावर 2 माइनस 2 हो जाएगा, 9 और -7। तो अगर नाउ इफ यू कंपेयर दिस रिजल्ट विद द गिवन रिजल्ट इन द क्वेश्चन, तो अल्फा की वैल्यू जो है वो 2 है, दिस इज अल्फा। सो इस पर्टिकुलर क्वेश्चन का जो आंसर है वो है 2। ठीक है, तो ये बेसिक क्वेश्चन था हाइड्रोस्टैटिक प्रेशर के ऊपर, जिसका आंसर है 2। सो फ्रॉम दिस क्वेश्चन वी कम टू एन एंड ऑफ आवर सेशन। ठीक है ना, तो मैंने कंप्लीट सोल्यूशन दिया है सारे क्वेश्चन का जेईई मेंस 2024 जो 27 जनवरी मॉर्निंग शिफ्ट का पेपर था। I hope you all can check that what exact you have done on the day of exam. So in the next video, I will be coming with another paper of 29th January morning shift. Till then, thank you.